We want to continue our review, and for number 3, the normal monthly precipitation in inches for August is listed for 12 different U.S. cities. Right here, 12 different U.S. cities. Are there more than 12 U.S. cities? Yes. So this is going to be a sample. Here are the values listed, and we want to compute starting with the mean. Well, since this is a sample, it's going to be x bar. We're going to add up all of these values. When we add those up, we get 37.3, and we divide by 12 because there's 12 different values. I'm going to divide by 12, and when I do so, I'm going to get 3.108333333. Okay? Now, if you notice, our data has one decimal value. Therefore, our mean should have 2 decimal values. So I want to keep 2 decimals. This one indicates that I round up. So the mean is actually 3.11 inches. So the mean monthly precipitation for August is 3.11 inches. Now we need to do the median. And for the median, I have to put these in order from the smallest to the largest. So I'm going to do 1.0, 1.6, 2.2, 2.4, 3.4, 3.5, 3.6, 3.7, 3.7 again, 3.9, 4.1, and 4.2. We have those in order. So now for the median, I need to find the location, which is going to be 0.5 times, and we have 12 values this time. So 0.5 times 12 gives me 6. So I'm going to take the 6th and the 7th. So 1, 2, 3, 4, 5, 6, and 7. So the median is 3.5 plus 3.6 divided by 2. The median will be 3.55. I am going to keep both decimal places because, again, my data has 1. These are going to have 2. The median monthly precipitation for August is 3.55 inches. Part C wants us to find the mode. It's one that will occur more often than some of the others, or any of the others. And so if we look through here, you'll notice 3.7 occurs twice. So that will be my mode, 3.7. So the mode, monthly precipitation, for August is 3.7 inches. For part D, we want to find the variance. So I'm going to go ahead and enlarge this so that we can see our writing a little bit better. For the variance, I want to take the value minus the mean, and the value minus the mean squared. So go ahead and write in your values here, pause the video, and then we will continue talking about it. Okay, I have written in the values. I didn't put them in order this time, I just put them as they showed in the table. Recall that this is a sample, and our sample mean was 3.11. So we're going to take 3.5 minus 3.11 and get 0.39. We will square that value and get 0.1521. You'll notice I'm keeping all of my decimal places. I do not want to round until the very end. So whenever I have 1.0 and I subtract 3.11 from it, I get a negative 2.11. I square that and I get 4.4521. Go ahead and see if you can fill in the rest of the table. Pause the video, and then when you restart it, we'll see that we have the same numbers. Okay, I have filled in the table with taking each of my values and subtracting the mean of 3.11 from them, and then I squared each of those values. Recall that this last column, they all have to be positive, and we want to keep all of our decimal places. We don't want to do any rounding at this point. Since we're looking at a sample, that's going to tell me that the variance, we're going to add up all of our values minus our means squared. So we're going to add up this last column, and here we divide by n minus 1. We're dividing by n minus 1 because of the fact that it is a sample. So whenever I add up this entire column, I get 12.0292. We have 12 values because there were 12 cities, so we're going to take 12 minus 1. So we're going to have 12.0292 divided by 11. Whenever I divide this by 11, I'm going to get 1.09356. My data has one decimal place, so I want to keep two decimal places. So my variance is going to be 1.09. Again, I want to keep 2 because my actual data has 1. So I'm going to come down and I want to look at the standard deviation. That tells me I'm going to take the square root of the variance I just found. Whenever I take the square root of it, I get 1.04403 and so forth. So the standard deviation I want to keep is 1.04. Again, two decimal places because my data is in whole numbers. We want to find the quartiles, Q1, Q2, Q3. So for Q1, the location is 0.25, and in this case we had 12 values. When I multiply this out, that gives me 3, so this means positions 3 and 4. So Q1, if I scroll back up, I want position 1, 2, 3, and 4. So 2.2 and 2.4. 2.2 plus 2.4 divided by 2. Q1 will be 2.3. Q2 is our median that we found in part B. So Q2 will be 3.55. Q3, that's going to be 75% of our data. So that's going to be 0.75 times 12. 0.75 times 12 gives me 9. So I want the 9th and 10th positions. When I scroll back up, looking at our data, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 3.7 and 3.9. Q3 will be 3.7 plus 3.9 divided by 2. So Q3 is 3.8. We want to find and see if there are any outliers. So we need to find our lower boundary and our upper boundary. So for our lower boundary, that's going to be Q1 minus 1.5 times Q3 minus Q2. Our upper boundary will be Q3 plus 1.5 times Q3 minus Q1. So I'd like for you to go ahead and see if you can solve these, and I want to apologize. This should be Q1, not Q2. So it's Q3 minus Q1. Pause the video, see if you can solve them, and then we'll come back and look at it. Welcome back to the video. We're going to look and see, did we get the same lower and upper boundaries? For my lower boundary, I did Q1 minus 1.5 times Q3 minus Q1. So I had 2.3 minus 1.5 times 3.8 minus 2.3. We do this subtraction, 3.8 minus 2.3 gives us 1.5. I'm going to multiply the 1.5 times the 1.5, which gives me 2.25. So 2.3 minus 2.25 will be 0.05. Upper boundary is Q3 plus 1.5 times Q3 minus Q1. So I have 3.8 plus 1.5 times 3.8 minus 2.3. Recall that this value right here is the same as this one over here, so I actually end up with 3.8 plus 2.25. That gives me that gives me 6.05. So let's go back up to our data and look at this. So whenever we're talking about it, my lower boundary was 0.05. It's out here. My upper boundary was 6.05. It's up here. There is nothing outside of these boxes. Therefore, there are no outliers. And that's important for whenever we start to look at our box plot. So now we need to draw a box plot. And I'm going to take it here. And I'm going to just start with 0. Here's a 1, 2, 3, 4, and 5. So here's half, here's 1.5, 2.5, 3.5, 4.5. And I'm going to make a vertical line at my Q1, which is 2.3. So it's going to be about right here. I'll make another vertical line at our Q2, which was 3.55. So about right here. And another vertical line at 3.8. So that's going to be about right here. And we box that in. Then what we need to do is we need to go back to our data where we had the box around it. Since there's no outliers, my whiskers, my dots, are going to go to my lowest value and my highest value. So 1.0 and 4.2. So I'm going to draw here 1.0, and then 4.2 is about here, and draw there. So there is our box plot. So now let's look at, given the following data set, find the percentile rank for a student that scored a 44 on the test. We're talking about percentile rank. Similar to quartiles and our median, we have to have these in order from our smallest to our largest. So we need to put these in order. So 10, 14, 15, 18, 23, 44, 56, and 72. Now that our data values are in order, we're wanting to find the percentile rank for 44. So when I look at this, here is 44. Percentile, we're going to take the number of values below, 1, 2, 3, 4, 5. We're going to add that buffer room of 0.5. We're going to divide it by our total number of values, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to multiply that by 100. So this gives me 5.5 divided by 8, not 5.8, 5.5. So 5.5 divided by 8 times 100, and we get 68.75. When we're talking about percentiles, we want to round up, so this rounds up to the 69th percentile. So a student that scored a 44 on the test is in the 69th percentile. Okay, well, let's look at the average weekly earnings in dollars for various industries. Find the 30th percentile. This one we're going the opposite way. We know the percentile, we're trying to find the value. First things first, we need to put them in order. So we have 547, we have 604, we have 649, 683, 706, 729, 755, 800, 821, and 851. Now that we have these in order, we're wanting to find what corresponds to the 30th percentile, so we need to find that location. 30th percentile is 0.3, and let's look and see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So I'm going to multiply this by 10. So I get position 3, which what that means is to take position 3 and position 4. So 1, 2, 3, and 4. I'm going to take 649 plus 683 divided by 2. That gives me 666. So an average weekly earning of $666 is in the 30th percentile. So an average weekly earnings of $666 is in the 30th percentile. Okay, a student scored 76 points on a test where the mean score was 82.5 and a standard deviation of 6.1. So that means that our mean was 82.5, our standard deviation is 6.1, and this particular student scored a 76. What is the student's z-score? Well, recall that a z-score is the value minus the mean divided by the standard deviation. So we're going to take that student's score, 76, minus the class mean, 82.5. We're going to divide it by the standard deviation. So 76 minus 82.5 gives us a negative 6.5 divided by 6.1. So the z is a negative 1.06557. We always round this to 2 decimal places. So that's a negative 1.07. So the student's z-score is a negative 1.07. The average weight of an adult male bison in a particular federal wildlife preserve is 1,450. So the mean is 1,450 with a standard deviation of 240 pounds. Find the weight of an adult bull whose z-score is 1.5. So z is equal to 1.5. Now there's a couple of different ways that we can work this. recall that z is equal to your value minus your mean divided by your standard deviation. So my z is 1.5. My value, I don't know, that's what I'm looking for. The mean is 1,450 and a standard deviation of 240. In order to rewrite this so that we can solve it, I'm going to multiply both sides by 240. When I do so, that gives me that 360 is equal to x minus 1,450, because recall that these two cancel each other out. Then I'm going to add the 1,450 to both sides. So add the 1,450. When we add the 1,450, we come out with a value of 1,810. So a bison bull with a z-score of 1.5 weighs 1,810 pounds. Okay, Gina and Stuart are surf fishing on the Atlantic coast, where both bluefish and pompano are common catches. The mean length of bluefish, so we're looking at the bluefish first. The mean length is 264 millimeters, with a standard deviation of 41 millimeters. The pompano has a mean length of 146 millimeters, with a standard deviation of 24 millimeters. So it tells us that Stuart caught a bluefish, so this one is Stuart, and his fish was 355 millimeters long. Gina caught a pompano. Her fish was 245 millimeters long. Who caught the longer fish relative to fish of the same species? When we're talking about relative to the fish of the same species, we want to find a z-score for each one. So we need to calculate a z-score for Stuart's and for Gina's. So Stuart's z-score is going to be 355 minus the mean of 264 divided by 41. When we subtract and divide, we get 2.219512, round to 2 decimal places. So Stuart's fish had a z-score of 2.22. Now, let's look at Gina's. Gina's was 245 millimeters long, compared to the mean of 146, divided by 24. Subtract and then divide, and we get 4.125, rounded to 2 decimal places. That's a 4.13. 4.13. So looking at their z-scores, recall that z-scores are the distance, how many standard deviations a value is from its mean. So Stuart's is only 2.2, where Gina's is 4.13. So Gina caught the longer fish relative to fish of the same species. Now obviously Stuart caught the longer fish, but bluefish are automatically longer than the pompano. So Gina actually caught a longer fish relative to that fish's species. Continue working on these and then let me know if you have any questions.